this fast. Move on. Of course, it takes a while for your computer to go. It's not completely screwy to get into Inventor at this point. We'll see why for Bean Calculator. Free your brain a little bit. It's going to be something depending on what you can do in the economy. So let's remember the basics of doing Inventor. First you sketch, and then you constrain, and this is already constrained, so I'm not going to constrain, and then you dimension, and then hopefully maybe you even change those dimensions to be something that makes sense. And if you notice here, then you dimension again, and I'm going to make that somewhat sense. You notice you've got to get units. You hit there, you zoom out however you know how, and then you hit, I'm going to go ahead and hit F, finish the sketch, hit F6, extrude, think about what you're doing. In this case I'm going to push both ways, in other words a ½ inch each, hit OK. Think about my coordinate systems. Maybe I want to take a look at the center point, see where it was placed. I might want to make that visible so I can see it. But when I'm done, I then do File, Save As, and I know where to put it. So I'm going to call this, I don't know, Jack and Jill. Do a better job. Figure out in the end how your directory structure works, so when you transfer things around, at least check, follow up with the facts. Hit a save there. We now have made one part. I'm going to show you now how I think Mr. Hall's doing this stuff, and it's a great way to do it. Open. We're going to go with a new, now we're going to do an assembly, and we'll just start making all of our parts from within the assembly. Now you could have started this way, of course, but I think it's generally a nice idea to bring in one part. I'm going to bring in Jack and Jill. Hopefully it's in here someplace. Learning you can go here and go to J is something many of us haven't put in our brains quick enough. I'm going to bring in that piece, hit done. Now I can go ahead and go back to design, assemble. I can create a new piece. I'm going to call it Jack and Jill 2. And I'm going to just, this time, hit OK, and I'm going to give it the face I want to design Jack and Jill 2 on. Pretty nice. It's very faint, and I apologize for that. But one thing you can right away do is then project your geometry, and you can grab that piece, and now you've got the geometry projected on there. So now when you go to a rectangle here, you can kind of go across, zooming out a little bit. Finish sketch. Extrude. This time I'm going to come out. And notice one of the things it did, it right away, sometimes it goes into metric. I don't know why that is, but you're going to grab the profile here. Grab the profile of your thing, and you're going to give it maybe 25 millimeters. Out. Hit OK. That part, return. That part's kind of done, just so you know. That part is done. So you can go now, go to another one. Zoom out here. And once again, you're going to create, this time it's going to be Jack and Jill 3. Hit OK. Grab the face. Right away now that is your sketch plane. I'm going to come across here. I'm just going to make this arbitrary. I'm skipping, of course, the constraint and the dimension. I apologize, of course, as always. And then right away you're going to extrude this one. You're looking at it from the back side. You can extrude it back out. We'll make this 25 millimeters. Coming back towards us. Hit OK. Return. Return. Those things, hopefully, when you look at them all, should be all kind of lined up through. Now, in fact, if you wanted to put holes in there, this indeed is one of those great things, I think. You actually have to go back within the part to do it. I'm sorry. You can do on the bolted connection. That was the part of the pointer. Bolted connection. Again, if these things don't work, I'm going to save this assembly. Jack and Jill. Ass 1. You're going to go your hole, your linear, we'll go in linear, we'll go ahead and pick a hole all the way through. My start plane is here. My linear edge here. Grab my linear edge here. Maybe I want it to be 3 inches. My linear edge here. And maybe I want it to be 4 inches. And the last thing I've got to do is do the termination, and that you have to look around the backside for. I want to terminate this on this plane. It does some calculations, gives you some things you might want to do, worry about. We'll probably come back to that hopefully by the end of the semester. If not, download this program. Alright, so now you've got your basic, you can do a bunch of different holes, and I think what becomes interesting eventually is to actually make those holes and get rid of the fact that they're holes and then make them just things like you did when you did things in AutoCAD. Okay, I'm going to go ahead and do File, Save. I'm just going to constrain this the easy way right now. Yes to all. I've got 3 minutes to do it. Real time all the way through a design, though, of course, not dimensioned and not put on a sheet of paper. We'll do that next. I go to here. I can go ahead right away now to environments, stress analysis. We know we're going to have to give them some parts. We're going to create a simulation. Hit OK. Lots of different simulations right away. What you want to do is you might want to do the material first. It might make sense to kind of go through this process like you do. Go to Material, right click, Assign Materials. Look at what you've got. Remember all kinds of different things. I'm going to try aluminum. What is the unit weight of aluminum? It is the unit weight of granite, they tell me. We'll check that in a little bit, right? Strength to weight. Strength to weight. You guys now are quite aware of strength to weight, but also get involved in the stresses that occurred. So you develop the sense and apply a fixed constraint just to this one face right here, which is odd. So we've essentially got a, we've got a cantilever. Now what I'm going to do here is I'm going to go out here, and we'll see about whether this other piece is constrained when we go back. We're going to go ahead and assign a load. Remember, we didn't turn these things around, so my load is going to be a minus y. So that's one thing to kind of get aware of. If you're going to be thinking about up should probably be z. We're going to go ahead and assign a load, a force, a location to the force right there out on the end. And we're going to make it, of course, then always using vectors. Minus 1,000 pound force. You remember kilogram force, pound assumes force. I hit an OK here. You've got a constraint along there. You've got loads. In the end, the last one is to do your automatic contacts. That should put a contact between a couple of these because they're touching. Don't know whether that's the case. Hit simulate, run. There's your stress analysis. So think about doing that. That's how long it takes. And then get some dimensions on it. Get a plot on an IDW, etc. I don't have time in these 10 minutes. That's making the plate and doing it. And then move on.